Hello, this is Matthew, and today we are going to install OpenVMS 8.4 for Itanium. That's right, I have an HP Integrity RX 1600 server, which is a dual Itanium server with two Itanium 2 1 gigahertz processors. And I have put that out in a data center that I have some space in because it's way too loud to have sitting in my room and record a video. It's quite annoying. But it's nice and tucked away somewhere where we won't hear it. But I do have the management processor card for it. So that lets us connect to it remotely, control its power remotely, and most importantly, for installing and managing OpenVMS until it's up and running on the network, we can access the serial console remotely. So without further ado, let's dive in. As I mentioned, we have the management processor, or the integrated lights out management controller for it. So I can connect to that over my VPN to my internal network out of the data center and log into that guy. So we're in. The server is turned off right now. If we look at the virtual front panel, we can confirm that. Power is off. The system is off, the locator's off, system power is off. So we can see up here system state. It looks like it figured out the power is indeed off. So that all looks good. We have a plugged in but otherwise powered down server. And we can change that by going to the command menu and using the power control command, giving it the on flag, and confirm that yes, we do want the system power to be turned on. So the system is being powered on now. Great. We can leave command menu and we can connect to the virtual console, CO. And this will now just connect the serial console of the system to my telnet session here through the management processor. So I picked up this machine several years ago. You can see the last version of the BIOS on the machine. The firmware was from 2007. I'm not quite sure when end of life on these RX 1600 machines was, but it's been quite a while now. So as they kind of went out of support and off lease, a bunch of them flooded eBay for a brief period of time where they were pretty readily available for pretty cheap. So I was able to pick up a couple actually, and over time I have gotten some other spare parts and upgrades. So I've maxed out the RAM at 16 gigabytes. I added the second processor, so there are now two Itanium 2 processors in here, 1 gigahertz apiece. You can see that here. You can see we have an Efi Boot Manager. So Efi isn't just for x86 hardware. It was developed to be kind of a universal firmware and boot system for a lot of different platforms, and Itanium used Efi. You can do the typical things in terms of boot configuration, your system configuration, adding boot up passwords, those kinds of things. But for now, I'm just going to boot off of that internal bootable DVD drive. So I had downloaded the Itanium VMS installation media from the HP Hobbyist program when that was available. And I left that DVD in the drive when I took this thing out to the data center, where it will probably just live forever. So I can always, reboot and reinstall if I feel the need to. So we'll go ahead and boot off that internal DVD. You'll come to find that most things on the system feel pretty slow. The hard drives are, we have two Ultra 320 SCSI hard drives, which was the standard fast hard drive for the time, the era when these servers were new. So despite being 10,000 RPM drives, they are still just Ultra 320 SCSI, which by today's standards just feels really, really slow for most I/O operations. So what I'm going to do is there's going to be a lot of time just waiting for things to happen during the installation. So I've kept the current real time down here in the corner of my screen session. And when I speed up the video, you'll be able to just keep an eye on that. So we'll be able to see kind of how long this took. In fact, I'm going to write down, we're starting the install around 1738. I think was probably when we said boot from the DVD drive. So at the end, I'll try and remember to check how long it took to install the base OpenVMS operating system. Now, the Itanium, for those that don't really know the history of it, you're probably familiar with Digital originally developing the VAX architecture, and that is what OpenVMS was initially developed on. VAX was a follow-up to their PDP line of systems. And as time went on, they needed to move into the future with a modern 64-bit RISC processor. And so that's when Alpha was developed. And that was the next platform for OpenVMS. That was that Alpha or Alpha AXP architecture. And that was a 64-bit RISC processor. As time went on, remember that was under the Digital, and then Compaq acquired Digital. HP had their PA RISC architecture. That was what their Unix systems ran on. It was a 32-bit CISC architecture. And HP started working on what they thought was the future, which was this idea of very long instruction word, VLIW processors. And so typically, if you've written programs in assembler, you're familiar with this. Every instruction encodes one operation. That could be add two numbers, or load a value into a register, or branch if the condition bit is set or unset, things like that. And so every computer program gets decomposed down into these discrete, kind of small minimum operations, and then you string lots and lots of them together, and you have a working computer program. The idea behind this very long instruction word architecture is that a single instruction can contain multiple operations, and the CPU is able to execute some of those operations simultaneously. So if you're aware of the, different pipelines or execution paths in the CPU, and if your instruction format allows you to encode, say, 3 or 4 operations in a single instruction, then a very clever compiler would theoretically be able to compile code in such a way that it can maximize the throughput of the CPU's ability to execute these different operations simultaneously. Now, it turns out, and there's a lot more history to why Itanium failed as spectacularly as it did, but it turns out that we ended up being able to just make existing processors that use the traditional instruction model much, much faster. And it was harder than I think people anticipated to write compilers that were smart enough to fully take advantage and optimize for a very large instruction word architecture like Itanium. So we ended up not really seeing any of the theoretical performance advantages. The traditional processors just became more and more powerful, faster clock rates, as well as adding better speculative execution and branch prediction and all of those kinds of things that really allow them to have the same sort of performance benefits that explicitly built simultaneous execution of operations could do. Now, we've seen, of course, some of the recent security vulnerabilities that come from some flaws in how well speculative execution protects one process from seeing what another process might be doing, but that's just going down a whole nother rabbit hole. Our system is booted now, so I'll get back to the task at hand, but the first thing you may notice if you're used to installing VMS for VAX is that rather than the installation media booting us into just a standalone backup prompt where we restore a save set to the disk that we want to install to, and then boot from that kind of minimal install on the disk to complete the installation, from the OpenVMS 8.4 media, we get this nice little boot menu, and it will actually perform the entire installation from the session that we're booted into off of the DVD. So I can just go option 1 to upgrade, install, or reconfigure OpenVMS i64 version 8.4. And this will get us ready to install. So again, at this point, rather than rambling on about the history of Itanium, I'm just going to speed up the video at any of the points where we're waiting for something to happen. Okay, we're given the option to initialize the disk that we want to install on or preserve the data. We're going to go ahead and initialize so we get a nice new clean installation. And it needs to know which disk we want to install on. So a question mark will list, but we'll see kind of our traditional VMS disks names. The DQA is the DVD drive. That's on an IDE bus, so there's both the master and slave device on IDE buses. There is no second device there, but it sees it because it technically exists as an option on the bus. That error there is probably it trying to detect a device that doesn't exist. But the important devices are DKA 0, which is the first hard drive, and DKA 100, which is the second hard drive. I'm not sure what the DAD 0 is. I'm not sure if that's a virtual device presented by the management processor or just something else in there. But we want to install on DKA 0, the first hard drive. Okay, it looks like this disk was previously labeled i64sys. We can either continue to call it that or give it a new label. That's the default system disk label for this version of OpenVMS. I will just go ahead and keep that i64sys label. We will use the newer version of the file system, so ODS 5. We will say that, sure, we'll go ahead and enable hard links, which is an optional feature of ODS 5. And yes, we're going to initialize that disk. All of the data on it will be lost, and we are using these options. Okay, now it's asking if we want to create a boot option in our Efi Boot Manager that will allow us to boot this installation of OpenVMS. That sounds like a really good thing to do because without it, we would have to guess some of the parameters ourselves. So yes, we do want to create that boot option. And it's asking if we need to pass any flags at boot. No, we'll just use the defaults of 00. Flags would, I think, let you do things like skip running the system startup scripts and other kind of troubleshooting and diagnosis options. But for our normal boot, we just want the default boot flags. We will set our system password. Okay, hopefully I remember what that is. And will we be a member of a VMS cluster? No, I'm just going to run this as a standalone machine. I won't install DECnet either because I don't plan on connecting this particular machine to HECnet or any of my other VMS-related systems. So we can give it a name. I'm going to call it MWVMS1. As I mentioned, I don't plan on using DECnet, so I can just stick with this default system ID. Since there aren't really any implications of that if I don't need to worry about setting the correct DECnet area and node number. Now it's asking about time zone. I am in the US and I am in Pacific time. And it's just asking for confirmation. Yes, US Pacific is correct. And yes, we are currently on daylight saving time, which makes -7 hours from UTC the correct time differential factor. So at this point, you could enter the license key for your base OpenVMS OS license or any other licenses you want to add right now, I suppose. But for the purposes of not showing the license key on video, I'm just going to say no to that. So without the OpenVMS license key installed, we'll still be able to boot OpenVMS, and we'll be able to log in as the system user from the local console. So once the system's installed, we can go ahead and do that and add the license key later. So it's telling you that you'll get all of these packages by default, and that we will optionally be able to install Deck Windows Motif, the 2 different versions of DECnet that we have available to us, and TCP/IP services. Okay, I am going to install Deck Windows Motif. Among other reasons, I will be installing Oracle database on this server, and its installer is a graphical program. We'll be able to do X forwarding over an SSH tunnel. but that may require some of the Deck Windows components to be installed. So I'll just say yes to that. No, I don't need DeckNet. And then it should ask if we want DeckNet Phase 4. There, DeckNet Phase 4, I do not need. I do want TCP/IP services. This will let us connect to the server, both inbound and outbound, with things like Telnet, SSH, FTP. So that will be our connectivity to the world. Do you want detailed descriptions of the next prompts? No. So now it's going to read all of the installation kits off of the installation media and validate their signatures. So this is a cryptographic signature that HP embeds in the product install packages. This will do two things for us. One, it'll just make sure if there were any problems burning that image to the DVD, they would be detected here as an alteration of the installation kit. Also, if somehow somebody tried to, give us fake, hacked versions of the operating system or utilities that has a backdoor or a security problem in it or something like that, assuming they didn't also alter the allowed signing keys and everything like that, this will catch any problems with the source of the installation kits. So this will take a while because, again, it's basically reading everything off of the DVD right now and computing the cryptographic checksums of it that will then be compared to the signing key that HP uses to sign all of the installation kits. Okay, looks like all of our kits passed validation, which is good. We can have confidence that we have a good DVD image burned without any errors. And it looks like we're going to start with installing OpenVMS itself, which makes sense. We'll just go ahead and accept all of the default options. This will give us just all of the base components of the operating system. We don't need to try and add or remove any particular options. We have something like 146 gigabytes of space on this DKA0 disk, so we'll be able to hold everything and not even really notice that it's there. So just gives us a list of everything it's installing. We don't need to review the options. And now it's going to go through and install all of these kits. So this being the base operating system with these components will be the bulk of the installation time. So I am going to relax and check in later to see when this finishes. And again, you'll be able to keep an eye on the clock down here to know how long we're sitting here. Okay, that was exciting. So it looks like that was part of the initial installation. I do want to scroll back up really quickly here. You can see that we have a note that we can execute sysmanager TCP/IP $config to proceed with configuration of HP TCP/IP services. So that is the same command we would use after installing UCX, the TCP/IP services for OpenVMS on VAX. So we'll just remember to run that when we are ready to set up our network interface. There's other notes if we want to use Kerberos, which we don't, and the WBIM providers, which we don't. So those will just sit dormant on our system since we're not going to configure and start them. Additional information about privileges and readmes for some of these other services. Now it's going to go ahead and install some extra patches that are built into the installation media. So this installation kit for VMS has the VMS update version 10 built into it. The Hobbyist Program distribution site had an additional update for VMS update v14, and that'll get us to the most up-to-date, most patched version of VMS that was available through the Hobbyist Program. All right. Well, that was all very exciting. We have completed the installation. It says we should now have a boot option called OpenVMS on DKA0. It's the first entry in the boot option menu. So it should auto boot if we don't interrupt the countdown timer in our boot menu. It's also letting us know that the first time we boot the system, it's going to automatically run autogen to set some system parameters, and then it will reboot the system automatically so that those new parameters take effect. So we can shut down now or continue with other. We'll hit return to continue. And we will shut down the system. Okay, the system is halted. Looks like we can hit any key to cold reboot. We will hit, I don't have an any key on my keyboard, so I'll just hit enter. And this will reboot the server. Remember, we're still connected to the server's serial console through the management processor. So we should just see that server boot process again and land back in our EFI boot menu. Okay, you can see we do indeed have OpenVMS, and it is the entry that will auto boot if we just don't touch anything. We'll see the note that we don't have the OpenVMS i64 license installed. That's because we chose not to set that up during installation. But again, that's fine. We'll be able to use it as the system user from the local console. And as the installation process told us, the first boot will automatically run autogen, and then it will reboot the system again so that any of the parameter changes take effect. All right, at long last, we have completed the base installation of OpenVMS on our Itanium server. So I can hit enter to get the login prompt. Log in as the system user with the password that I set during installation. And here we are at the DCL prompt. I can show system. You can see we're on OpenVMS 8.4. Here's kind of the minimum set of processes that you get after that initial boot, after an initial installation. And we can show the product. Let's see, it's actually product show history. So this is everything that was installed. We have those base components, OpenVMS, and some of those default components it comes with, as well as some of those patches that got installed automatically by the installer for the software installation system. That's what PCSI is. And then OpenVMS update version 10. So what I'm going to do now is pause the video for a second and copy and paste my license key for VMS in here. The base VMS license key is called OpenVMS-i64-FOE. That includes the license for TCP/IP, so it's not a separate license key for UCX like it is with the VAX license pack. So I will do that and be right back, and then we'll finish this initial installation just by configuring and enabling TCP/IP, as well as making our second hard drive available as a data drive. Okay, welcome back. I've installed my license key and hit enter enough times to scroll it off the top of the screen. I will point out the time. So we are 1 hour and 10 minutes from the time that we first told the system to boot from the installation DVD. So I think we went through things pretty quickly. I didn't really wait and pause while I was talking at any of the installation prompts. So I think it's fair to say that it takes about an hour, a little over an hour, to install a nice, clean, new OpenVMS version on this system. So let's see. The installation guide for VMS 8.4 has a couple of items that we can take care of quickly for post-installation tasks. The first is to create the network proxy authorization files. This will allow remote authentication over things like DECnet. Probably not something we need to worry about, but creating the files will prevent some error messages from printing to the log every time we boot the system. So we'll set default to sys common sysexe. I need the brackets around the directory name, sysexe. And then we will say MC authorize create proxy. And it looks like that had a normal successful completion of creating the proxy database, but we don't have any network enabled yet. So that's what this net no device available message means. And then we'll just set our directory back to whatever our default login directory was, which is sys login. We'll also create the initialize the queue manager and create our system batch queue, kind of the default batch queue. So we start the queue manager and we tell it that we're on a new version. This will get everything set up with a new queue manager database. And we can then initialize a queue and we'll start it, and it will be a batch queue called sys$batch. So that creates our sys$batch queue for us. And last but not least, let's get this on the network. So we can use that TCP IP $config script. So you run DCL command procedures by using the @ sign and then the command procedure name, which usually ends with .com. So sys$manager TCP IP $config.com. If you leave the .com off, it will look for the file with that extension by default. And here's the TCP IP configuration procedure. So we'll just go through the menu quickly. The core environment, you can tell it the domain. My lab domain is lab.mattwilson.org. Interfaces is where we'll configure the network interfaces. This server has two network interfaces. One is a fast Ethernet interface, and then one is a gigabit Ethernet interface. We'll configure the gigabit interface because that's what I have plugged into the network switch. I'll add a primary address. We will not use this address for clusters over IP, and this is going to be 192.168.64.13, I believe is what I assigned it on my network, and that is in a Class C address space. The host name will be the same as my system name, which is MWVMS1, and we can confirm that all looks correct. Yes. Okay, we can leave the other interface unconfigured and go ahead and exit this menu. Routing, we need to set our default gateway. We're not going to use a dynamic routing protocol. We do want to set a default gateway, and that's 192.168.64.1 for me. We don't need to give that a host name. Bind resolver will let us do DNS lookups. My bind server in this network is 192.168.64.5. Don't need to give it a name, and I don't have any additional bind servers. And finally, number 5, the time zone. It should just inherit that from our system setting, which is correct. So we hit enter there. So exit that menu. Now, to use the TCP IP clients, we actually need to enable them. So I want the FTP client to be enabled on the system. So I'll enable that service on this node. We'll configure the servers later, so I'll just say no to that now. I also want the SSH client enabled, so we'll just do number 7, enable. That creates a number of items in the authorization tables. Again, servers we'll configure in a minute. and Telnet. I want the Telnet client to work, so we will enable that. That looks good. I don't think we need any of these other ones right now, so I can exit that menu. And the server components. I would like to enable, it looks like the Telnet server is enabled by default, and that's fine. The rlogin server is enabled. When the Telnet server is enabled, you can't separately control them, so nobody uses rlogin anymore, or really shouldn't be using Telnet anymore either, but we'll leave it because this is only being accessed over a secure VPN connection to the network that it's on. But the ones I do want to enable, FTP, I will enable the FTP service. That'll be the easiest way to get files onto this system. I'll go ahead and enable the SSH service so that if I am connecting to this over the internet, it will be a nice encrypted connection. And we'll go ahead and create the SSH host keys. Again, the performance of this 1 gigahertz Itanium 2 processor, this kind of SSH host key creation is something that would be nearly instantaneous on just a modern x86 system. Okay, the SSH client is already enabled. So looking through the list, I think those are all the services I am going to enable for now. You can set up things like IMAP and POP if you want users to be able to access their email on the system remotely. NFS if you want to be an NFS server to allow volumes on this server to be mounted from, say, your Unix systems. But my basic connectivity needs are covered by FTP and Telnet and SSH. So we can exit that menu. May as well start up the services now. So if I say 6, that's activated the TCP/IP interface as well as those various services that we requested. And we can exit the configuration menu. So now I should be able to ping. Let's see if I can ping my router. Yes, I can. Excellent. And I should also be able to ping something outside of my local network. We'll just ping that 8.8.8.8 DNS server. Perfect. And one last test, I should be able to ping by DNS name. So if we just ping google.com, perfect. We're able to resolve DNS names. Okay, the last step is I'm going to need to set my terminal device. We are going to inquire, and it should auto set up the parameters. So now if I show term, you can see it detected it as a VT100 capable terminal, and it auto detected my width and my page size. So now I can use the full screen editor. We're going to edit the sys startup startup_vms.com file. And this is one of the files that is run at system boot time. So this is where you put any site-specific startup commands. We need to add a couple of things here. Shortly after the message that we're now executing the site-specific startup procedures, I am going to add a little section here for what I'll call early commands that I just want to make sure are available before anything else runs. One of those is going to be our mount command for that second hard drive. So that's mount. We're going to mount this for the whole system. The device name is DKA100, and the volume label will be data. And we haven't initialized that yet, but we'll do that next, just so that it's ready for us next time we reboot. And that should be good for now in terms of our early commands. And the other things we need to do, we just need to find where the system batch queue is started. And we'll uncomment that line since we set up the queue manager and created that queue. We didn't create a print queue. Here we go, start queue sys batch. So that will automatically start that sys batch queue that we created. And there will also be a commented out line toward the bottom that starts the TCP/IP services. Here it is. So we can uncomment that line, and now on system boot, those TCP/IP services will start. Okay, I'm going to hit Control Z to save and exit the editor. And with that, I think we're going to call it good. So we installed OpenVMS on a new Itanium server. We set up TCP/IP, and then we just made some basic configuration changes to our startup script so that our services start on startup. Oh, and actually, we added that command to mount the disk. So we need to make sure we initialize and format that disk. So you can say initialize DKA100, which is that second hard drive. And we're going to go to the label data. Okay, that's initialized. So now we can mount it system-wide DK100 data. And if we show devices that are mounted, we should see our two hard drives, DKA0, which is our i64 sys volume, which has plenty of free space, as well as DKA100, which is our data volume, has even more free space. So that's it. I will log out, and we'll consider this a successful base installation of OpenVMS and TCP/IP services on our Itanium server. Probably in the next video, I'll show just how I do some basic customization of the system to get it into what I consider kind of the minimal usable state for me. And then that video will also be pretty applicable to VAX and Alpha VMS installations. So that may be more interesting to you if you don't have an Itanium system to run through this initial installation on. But as always, I really appreciate your watching the videos. Leave any questions or comments down below. If you liked the video, I love seeing those thumbs up. They let me know that you guys are out there and appreciate what I'm doing, which always feels good. And if you want to see more videos about old IBM mainframe stuff, some AS400 stuff, and this kind of OpenVMS content, you're welcome to subscribe to the channel so that you can see when I post additional videos. Thanks again for watching, and I will see you next time.